Today we're going to be talking about measures of angles and arcs. Okay, so a major arc is greater than 180 degrees. So find a diameter, and I have one kind of highlighted here in red. And start at one point on that diameter. So I'm going to start at P and circle around so that you go past the other point that's on the diameter. So I'm going to write that as P going through U, and then all the way to S. So that's that arc. I could not just say arc PS because I don't know if arc PS is the one that I have highlighted here in red or the one that's in green. So you have to name it by 3 points. A minor arc is less than 180 degrees. So looking at that same diameter, PT. Okay, an example of a minor arc would be PQ. And that's just the piece that's less than 180, less than 180 degrees. A semicircle, half the circle. Exactly 180 degrees. Meaning, I'm going to erase some of this. So, meaning you could say PUT, or you could say PQT, you could say PST, okay? So there's a bunch of different things. And notice how when I'm naming arcs, I have a little arc over my 3 letters or 2 letters. Central angle is an angle with the vertex at the center. So my vertex is at the center. Any angle where my vertex is at the center, I'm going to say angle PRQ. And again, these are just examples of one. There's multiple examples in this picture. Central angle versus central arc. So meaning the measure, so I have angle PRQ here, and then we want to talk about how that relates to this, the measure of that arc. The angle equals the arc measure. Okay, so the angle equals the arc. And that is only if that angle's vertex is at the origin. Okay. Sum of central angles. The sum of the measures of the angles in a circle is 360 degrees. Okay, for this one, this example, solve for angle X. So you have a 20 there, you have a 5x plus 5, a 3x minus 3, an 8x minus 4. QT is not a diameter. TS is a radius. So I don't know what this last angle is here. I don't have something in there. And so I was actually working on this last night. I was like, oh no, what do I do? What I didn't notice is that you have a semicircle here. RSV is a semicircle. So 8x minus 4 plus 13x minus 3 plus 5x plus 5 equals half my circle, 180. So, combining like terms, I get 26x minus 2 equals 180. Adding 2 over and dividing, we get x equal to 2. Okay, WC is at the center, is the radius. WC is a radius. Looks like we have a right angle. We need to identify each major, minor, and semicircle, and then find its measure. Okay, so x, z, y. So x, z, y is this. I know I go through z because z's a part of my symboling there, my writing. So that is a semicircle. And that is 180 degrees. W, Z, Y. So I start at W, I move all the way around my circle through Z, and get to Y. That is a major arc. And all I have left over right here is this angle, which is 90 degrees. So 360 minus 90 is 270. Lastly, XW. XW here, I have a right angle here, so that is a minor arc, and its measure is 90 degrees. Okay, the next example. I need to find the measure of arc KL. Well, it says in this pie graph that we're at 21%. So 21% of that whole thing is our comfort bicycle. So that means that 21% of 360 degrees is what KL's arc is going to be, and that is 75.6. I have N through J, and going all the way over to L. So adding all of those percentages up, that's 84% of my entire circle, which is 360. So that is 302.4. Okay, arc addition postulate. Kind of like how we had segment addition postulate, an angle. You can add the arcs together. Okay, so they tell me angle HMI is 32. So that means that arc is 32. This one's 90. I'm looking for LHI. So I'm looking for the measure of that arc there. Actually, that's easier than I thought, because I have a right angle. LJ is a diameter. I have another right angle here. So that is equal to 90. And then I'm going to do a little bit of erasing. I, J, K. Going around there, we know HK is the diameter, so that whole thing is 180. What do I have to subtract? I have to subtract this little arc of 32. So that gets me 148. Okay, arc length. Okay, actually I'm going to kind of make this a little bit bigger. Let's see if I can do this. It's not going to let me do it, and I'm recording a video. Okay, never mind. Okay, the ratio of the arc length of an arc L to the circumference is equal to the ratio of the degree measure of the entire arc. I'm going to pause this and try and make this a little bit bigger for you. Okay, I made that bigger. I apologize. Okay, so really what this means is the length of this arc is some proportion of the whole circumference. That makes sense. but you need to have a central angle. So make sure it's central angle over 360 times by whatever the circumference is. So the length of DA, where is DA at? DA is right here. Okay, my radius is 4.5. The angle, I'm going to call that angle theta, is 40 degrees. So it's theta over 360, what proportion of the whole circle is it, times by 2 pi r, because this is some percentage of the whole circle, times by what the circumference is. So I have 40 over 360 times by 2 times by pi times by 4.5. When I plugged that in my calculator last night, I got 3.1415, a 9 and kept going. It actually simplified to be pi, because I guess 40 times 2 times 4.5 is 360, so everything canceled. It was just kind of a fun thing that happened to me last night. I was very confused for a minute. Okay, find the length of DA here. So DA is this arc here. Okay, I know ADC is a semicircle, so what's left over here is 152. 152 over 360 times by what my circumference is, 2 pi times 6, and that ends up being 15.92. And our last example, C. Find the length of DA. Oh, this is an easy one. Actually, I want you to pause the video. Try this on your own. And then restart. So hopefully you tried that on your own. Okay? And it is 2 pi times 6 times by the ratio of my angle, 140 over 360, and 14.66. Okay? Okay, so that is our video on measuring angles and arcs.